next relay we want to test is a transformer differential relay, three-phase. So I'm going to hit my test list. I'm going to come down here and I'm going to select transformer differential, and that's going to take us to the nameplate or configuration screen for setting up the test. Here we see the model for the transformer differential relay test, and we have two types of models available. We see the ANSI model here, and we also have an IEC model available. Up at the top we can see where we can put in the primary and secondary voltage ratings of the transformer along with the MVA rating of the transformer. We also can put in the CT primary and secondary, so you can have 1, 2, 5, whatever the transformer ratios are. And once that information is input, the software will automatically calculate the secondary currents for the CTs as well as the primary currents. Then we can go in and we can select the transformer vector group. In this particular case, we're going to use a Y delta, so we'll do a grounded Y delta, all right, and with an even vector group. And you'll notice it will even come up and tell you to ensure that automatically computed single phase pickup values match the factor specified on the relay manual. So for each different relay you may have different values associated with the even and odd vector groups, whether the relay is connected in Y delta, delta Y, YY, etc. And you'll notice it automatically selected the zero sequence elimination is enabled, so that, for example, on an ABB RET 670 or even like the Siemens 7UT613 with an even vector group, you will have a zero sequence elimination multiplier of 1.5, so that when we do a single phase to ground fault simulation, the relay doesn't trip on the zero sequence. If you don't have zero sequence elimination, then you would simply disable it. We'll leave it enabled. If you're using interposing CTs, you would click on that and you would put in the CT multipliers for your interposing CTs. But in this particular case, we don't have interposing CTs. That's the information for the transformer that we're trying to test. Now for the relay. Down here we see all the relay settings, and so we see pickup values in per unit. And for this particular relay we want to test, we're going to use a 0.3 value. The trip time is associated with the time it takes for the relay to operate. And then for the pre-fault values, we're going to apply 100% of pre-fault. Now in some cases the ratios may be such that you may not want to apply the full pre-fault values. You may want to apply maybe only 50% of pre-fault. And then how long the pre-fault gets applied. In this case we're going to use 500 milliseconds. The off delay is 50 milliseconds. Now the reason for off delay is once the relay tells the breaker to trip, we leave the currents on for another 50 milliseconds before the relay actually sees the currents go to zero, simulating a breaker opening. We're going to simulate, or we can use a binary output context to actually have the relay see the breaker open, and we would delay the contacts opening by 50 milliseconds. And the reason we do this is some of these relays also have breaker failure detection, so that if it told the breaker to trip and it tripped immediately, then the relay is not going to see the right information. It still expects to see current flow for a period of time, and it needs to see the breaker actually open. For through fault, again, we may need to apply less than 100% depending on the relay settings. So we want to simulate a fault through the zone of protection. You can go in here and you can adjust this to apply different through fault simulations. For second harmonic restraint, in this case it's 15%, but you could have a 16, 17, 20%, whatever it may be. You would put that value in here. And how long, when we pulse the current onto the relay, we're going to be simulating it for 500 milliseconds, looking for the relay to pick up or not within that time period. The tolerance values, we're going to use a plus or minus 10% on current. We're going to use plus or minus 10% for time tolerance plus 50 milliseconds. Again, we can simulate the breaker opening and closing using a binary output. And if we want to use a reference voltage, we can also do that. And then the tolerance on your harmonic restraint, again, we're going to use 10%. For the harmonic ramp mode, ramp to no operate says that we're going to apply fundamental current and increase the harmonic content until the relay goes into restraint. If we select ramp to operate, then we're going to apply restraint current and reduce the restraint current until the relay goes into operation. Either way, it depends on the relay manufacturer. So whose relay you have depends on which of these two you use. If your relay also has third or fifth or seventh harmonic, you want to run an additional harmonic restraint test on the nth harmonic, you would put that percent in here. And we've already talked about the nameplate format. Now we want to talk about the slope characteristic for relays. We've got 4 different slope characteristics. We have line segments. That would be if you had like a General Electric SR745 relay. It uses line segments. We have slope through origin. We have slope from x-axis. We have slope from base point. And this is the one we're going to use. This is a typical for an ABB RET 670 relay. It uses slope from base point. The Schneider P63X relay also uses slope from base point. That's the one we're going to use. For your restraint equations, we have 7 different equations available depending on the relay that you're using. Different relays have different restraint formulas. For this particular relay, we're going to use the absolute value of the primary or secondary. Also, General Electric SR745 relay, the GE Multilin 745, and the GUR T60 and T35 relays also use this same formula, or restraint equation. Unrestrained pickup, we're going to use this 8 times pickup value. Now we get into defining the slope characteristic from base point. Okay, well the base point is the pickup value of 0.3 per unit. So that's where we're going to start at. It extends over to a start point for slope 1, which is going to end at 1.25 for this particular relay. So 1.25, okay? And then from that, the slope gradient is going to be 40%. So I'm going to change that to 40. And then the knee point between slope 1 and slope 2, which is the end section value, which is going to be 3. So I'm going to come over here, I'm going to change this to 3.0. And then the slope gradient from that point up to the unrestrained pickup value is 80%. So I'm going to change that to 80. So now I've defined the slope characteristic for the relay we want to test, and all I have to do now is hit the green check button. It's even going to show us how to connect up the relay primary and secondary windings from the test set we're using. And then it's going to take us over to the test screens. We'll see a list here. We're going to start off with a stabilization test, or the through fault test. We also have a timing test where we can time each phase. If you click on the play button, it's going to say run all remaining tests or run the test we're selecting. To do a pickup test, again, we're going to have the 2 windings, 3 phases, or winding 1 and winding 2, and then we can also do a 3-phase test. If I hit the play button, it's going to let me select which winding and which phase I want to test. If I hit the play all button, it will just automatically go through and do all the tests automatically. And then the characteristic test, let's go ahead and do a simulation here. What we see is the characteristic for the relay based upon the setting values that we input. All the user has to do now is come in and touch the screen where he wants a test line, and it will automatically calculate all the test currents he's going to need to perform that test at that particular test line. So let's say, no, we don't like that, we put it in the wrong place, we want to move it. You simply come over here, say delete that one. It says, are you sure? Yes. Come back, hit it again, and now you've created your test lines. In this case, we're going to do 5 test lines. We can do individual tests one at a time. We can come in and say run that test. As it goes, it's going to apply the pre-fault. It's going to start ramping the current up. So it's pulse ramping the current, and you can see the current value is changing. The operating current is being slowly increased until we get up to a point. Now we're within the characteristic of the relay, the acceptable characteristic, and you'll notice that the vector changed color from red to green, and it's closing in on the operating characteristic of the slope of the relay. And when the relay operates, it captures that test result and it appears as a green dot. If it were to operate before or after the acceptable range, it would show up as a red X. If you run all tests, it just automatically run through and do all the tests automatically. Again, you can also come over here and say run all remaining tests. So you can run each one of them individually, or you can pick up where you left off and it'll pick up and start running from there. Again, you'll see the operating current coming up, and you'll see here's the 2 currents we're applying to the relay, and it's looking for the relay to operate. And then when the relay operates, we'll capture those test results and give a pass-fail determination. We also have the harmonic block test, and again, you can come over here and you can select doing winding 1, phase 1, 2, 3, or you can do 3-phase test, etc. And it will run those individual tests, or you push the play all button and it'll run all the harmonic tests on both windings for all phases and 3-phase. When you get through with your test, then you simply come over here and you hit the report button, and so you want to review the report, and you'll see the header information just like we had on our previous test reports. You'll see the model for the transformer we're testing along with the primary and secondary voltage ratings and CT ratings. You'll see the relay settings and the slope characteristic settings, and that's on page 1 of the report. On page 2, we'll see the test that we did earlier, the 2 test points for the slope characteristic of the relay. And each one of the test results will be recorded individually, so you will have a multi-page report when you get through. It'll show your pickup, winding 1, winding 2, through fault, slope, harmonic restraint, etc. for the transformer under test. And when you get through, you can then save that test result, and then you can export it to a memory stick, and then you can take it back into your office and hook it up to your computer, download it into your computer, and do printouts and save it to database, etc. To learn more, simply go to the Megger website and download the information for the Megger software.